Hi, I'm Miss H, and in this video we're going to be looking at phase changes. What exactly is a phase change? Well, if you remember from our previous video, a phase of matter is either a solid, liquid, gas, plasma, or BEC. We're going to focus today on phase changes between solids, liquids, and gases, since those are the three that we know of here on Earth and are familiar with. A phase change occurs when a solid, liquid, or gas changes to another phase of matter. Phase changes are called physical changes because the chemical makeup of the substance, such as H2O, does not change. Only the way that it looks changes. Most phase changes require that we either add or remove heat in order to make them occur. When you take a graph of the data of how temperature changes as heat is added to the substance, it's called a heating curve. By the same idea, if you make a graph of how the temperature changes as heat is removed, it's called a cooling curve. Let's take a look at an example of a heating curve. Here's the data table that we used to create the heating curve we'll see in just a moment. In this case, we started with solid ice, water, H2O, and eventually turned it into water vapor, or water gas. As you can see that in addition to the time and temperature columns, we also have an observation column. The observations are important for being able to figure out what is happening with the substance as the temperature changes. Here we see the graph that we were able to create by placing time on the x-axis and temperature on the y-axis. Notice that on this graph we have two flat areas. These flat areas correspond to the melting point of water, 0 degrees Celsius, and the boiling point of water, 100 degrees Celsius. If we were to compare these points to our observations table, we would see that at the melting point, 0 degrees, where we see that temperature, we saw that it started out at 100% solid and slowly changed over to liquid. If we look at the one with the boiling point, we'll see that we start out with all liquid and eventually become all gas. During the actual phase change itself, we see both. At all other times, we see either all solid, if we are below the melting point, all liquid, if we are between the melting and boiling points, or all gas, if we are above the boiling point. It's important to notice this, especially the fact that these areas right here are flat. That means that while the actual phase change is occurring, the temperature of the substance is not changing. Instead, that energy is going into moving those particles faster and faster, which causes them to move further and further apart. And that's how we go from a solid to a liquid to a gas. Because we don't see an actual temperature increase, we say that this heat is hidden. The word latent comes from the Latin word for hidden, so we call it latent heat. Now we want to look at the 6 types of phase changes. So again, let's look at how our solids, liquids, and gases look when they're in their particle state to understand better how they change. Remember that our solids are nice and neat and organized and very close together. Our liquids are random but still close. And our gases are random and spread out. You probably already know that as you take the nice organized solid and change it to a random liquid, we refer to that phase change as melting. And you know probably that the opposite of melting is freezing. When you change from a liquid to a gas, most of you would probably want to say that it is either undergoing evaporation or that it is boiling. However, these terms are too specific, so we want to use a more generalized term, which we call vaporization. Evaporation happens only at the surface of the liquid, but it can occur at any temperature. Boiling happens throughout the liquid, but only happens at a specific temperature. Vaporization encompasses both of these terms, so that's why we're choosing to use it on this diagram. The opposite of vaporization is condensation. These are all things that you're probably very familiar with and see every day in your lives. However, there are two additional phase changes that you're probably less familiar with. The first is called sublimation. If you've ever played with dry ice, such as at Halloween or as part of a science experiment, you'll have seen sublimation. Dry ice is made of carbon dioxide. Carbon dioxide has melting and boiling points that are very close together, and so it pretty much doesn't exist in a liquid phase under normal conditions. So when you take a block of solid carbon dioxide and expose it to room temperature, it sublimes, or goes directly from a solid to a gas without ever becoming a liquid. In order to create that dry ice, the company had to make the gas undergo a phase change called deposition. Deposition occurs when a gas turns directly to a solid without ever becoming a liquid. A place where you may have seen this in your everyday lives would be when you wake up and find frost on your window. The water vapor became solid ice without ever becoming liquid first. You'll also notice on this diagram that some of the lines are red and some are blue. The red lines are phase changes that are endothermic. Endothermic phase changes require you to add heat to make them occur. This prefix endo means enter or into. Therm refers to heat. So this means that heat enters or goes into the substance. The opposite of that, our blue lines, is called exothermic. Exothermic changes require the removal of heat. This prefix exo means exit, leave, or outside. And again, therm refers to heat, so this is heat leaves, or heat goes outside in order to make the phase change occur. Let's summarize what we see on this slide. The change from a solid to a liquid is referred to as melting and is an endothermic change. The change from a liquid to a gas is from a liquid to a solid is referred to as freezing and is an exothermic change. The change from a liquid to a gas is called vaporization and is an endothermic change. There are two types of vaporization. The first is called evaporation. Evaporation occurs only at the surface of the liquid, but can occur at any temperature without the addition of heat. Boiling occurs throughout the liquid, but only at a specific temperature. Changing from a gas to a liquid is called condensation and is an exothermic change. The change from a solid to a gas is called sublimation and is an endothermic change. And finally, the change from a gas to a solid is called deposition and is an endothermic change. This sums up everything that you need to know for phase changes for our class. As always, if you have any questions, please feel free to send me an email.